Hello, we want to introduce our application, the SQL Embedding tool, which lets you embed text directly from SQL. The Musketeers Brazil team created this tool, and you're welcome to help us improve it by asking anything or making pull requests. Let's start by recapping InterSystem's current suggested way to handle text embedding. This example was adapted from InterSystem documentation. First, you must create or use an external Python function that loads an embedding library, gets one or more strings, and returns their embeddings. Then, once you have your embedding vectors, you can issue a SQL statement passing your embeddings as an argument to be parsed by the SQL function of vector. But if you have to just use SQL for some reason, our application allows people who need or just want to skip the Python step and use just plain SQL. Of course, you keep using Python, but now under the hood, directly from SQL. Our application can be accessed by the SQL function dc.embedding. Its first parameter is the text you need to generate its embeddings. The second one is an identifier for the embedding provider, the Python lib, and the model name recognized by this provider. So, it allows you to use different embedding providers. Currently, it allows using models from Spacey, Fastened, OpenAI, and Sentences Transformers. If you are interested into another provider, please let us know. Also, as an open source project, contributions are very welcome. In summary, it's another way to use embedding with SQL in addition to the currents. We can take advantages in creating a function to centralize handling text embeddings. One of them is manage cache for embeddings. Let's check out it in action. Here, we can see that the model took 1.5 seconds to return the embeddings for a string. Then, we re-executed the same query, but this time the same query took only 0.9 seconds thanks to the cache. The cache implementation is straightforward. It's just a table. You can use SQL to operate on it, such as cache invalidation. In addition to the cache functionality, some other helpful features for handling embeddings could be implemented, such as give more power to cache engine using local embeddings to search for similarity instead of exact match. This could help to reduce the costs and latency. Some embedding model has better performance in certain domains than others. You can create a custom provider to mix models based on heuristics. You can implement a tracking engine based on the provider being used. This could help to track billing and where imagination takes you. As we said early, this tool is another tool to help you use in vector search. But as always, there is no silver bullet. So, this tool has some limitation regarding speed. The first execution of each provider or model leads to an import, and such operation is expensive and can take a few seconds, but the next call will not suffer that and will execute way faster. The embedding libs generally provide a method to process an array of strings. This leads to fast execution in bulk operations. However, we process one string for each function call so far, so our tool currently is slower than the version using Python directly. It's demo time. And it's all for today. Hope you enjoyed and found this tool suitable for your needs. If you have any question or suggestion, please reach us out in the project GitHub page. Thank you for your time.